Hello, I'm going to be doing the transfer function, discrete transfer function uh, command for Matlab. So if we have this transfer function here, a way to write this in Matlab is by looking at the coefficients for the numerator and the denominator. So in this case, for the numerator, we have 1, 1, 0.8. And for the denominator, we have 1, negative 0.9, 0.3. Now, since this is a discrete transfer function, we must specify a sampling time in seconds. So in this case, we're going to do 1 millisecond. And to identify this as a transfer function, we must use the command tf parentheses numerator, comma denominator, comma, then the sampling time. So this gives us our transfer function as shown here. If you want to write this as an expression, then you could do this command first, and then just typing in the expression as seen here for the transfer function. That should give us the same results. If you have multiple inputs and outputs, as shown here, where the first column is your input, the second column is your second input, and your rows are your corresponding outputs, then we could do this command here, where we still specify where we specify the numerator coefficients. However, since we have multiple numerators, we must put this bracket here, and then we type in the numerator for it. As an example, this 1 belongs to this numerator here. We space that out, and we write the second numerator on that row, which is 1, 0. There's no more numerators in this row, so we put a semicolon, and then we identify the other numerator down here, negative 1 plus 2 is here, and then 3 down here, closing the bracket. And then since we have multiple inputs and outputs, we could name our inputs by putting this command, by adding this command here to the transfer function, and then with the bracket specifying the first input, which is this one here, this column, second input, this column, and then the outputs for the rows y1 and y2. Now, to know more about your transfer function, we could use the command rlocus, actually ltiview, and going to the edit window, go into edit, go to plot configurations, and you could see different responses for your transfer function. This is the step response. We got the inputs response, also your Bode plots for your magnitude and phase, and you can also see your poles and zeros, reference to the unit circle. If your poles are within the unit circle, that means that your system is stable. This concludes the transfer function command tutorial. Thank you for watching.